Hello, welcome to one of my videos on basic math skills for A-level physics. Today we're going to look at one of the most important skills that you need to really master, and that is rearranging equations. Quite often we're given an equation on the data sheet and we need to make a different variable in that equation the subject. Now I'm going to go through rearranging equations the way I was taught how to rearrange them many years ago. And it's really simple. I was told by my maths teachers, my physics teachers, that whatever we do to the left-hand side of an equation, we must do to the right. And if you follow that rule, whatever you do to the left, whatever you do to the right, you cannot go wrong. You may not necessarily rearrange the equations very quickly, but you will rearrange them correctly. So let's look at a real simple equation. Y equals x plus 3. So let's say I want to make x the subject. By x the subject, it means I want x on its own on one side or other of the equation. So if I want to get x on its own, I'm going to need to take away 3 from the right hand side. But if I take away 3 from the right hand side, in order to keep the equation balanced, I must take away 3 from the left-hand side. So the left-hand side becomes y minus 3 and the right-hand side becomes x. I have made x the subject. Let's go for another one. Y equals 4x. Well, I want to get rid of 4 from this side. I want to again make x the subject of the equation. So I want to have something equal to x. I want to get rid of 4. It's 4 multiplied by x. So if I want to get rid of 4, I need to divide the right hand side by 4. But if I divide the right hand side by 4, I must divide the left hand side by 4. So divide the left hand side by 4, y over 4. Divide the left hand side by 4 equals x. Again, I have made x the subject. X is equal to y over 4. Let's go for another one that seems to throw people a little bit. Y is equal to a half x. Now I want to get rid of the half from this side, and I could say I want to divide by a half. Now, there's a few ways of writing this. A lot of people just want to write y divided by a half. I've divided the left-hand side by a half. If I divide the right-hand side by a half, I just get x. I don't think that's a very elegant way of writing the equation. I don't really like to see a fraction of a fraction. So what I'm going to try and do is get rid of this, not divide y by a half, but I can do something else. If I divide by a fraction, that is exactly the same as multiplying by the reciprocal of the fraction. So the reciprocal is 1 over the fraction, or the upturning of the fraction. So dividing by a half is the same as multiplying by 2 over 1. So let's see what happens if we multiply both sides by 2 over 1. So I'm going to get y multiplied by 2 over 1 equals x. Now 2 over 1 is just the same as 2. So we have 2y equals x. I think that's a much neater way of writing what is the same as we have here. So those two equations are the same, but that is a much easier way to look at it, I think. Okay, let's try another one. I don't know where that b came from. Let's get rid of it. There we go. Okay, so y equals x squared. Well, I don't want x squared, I just want x. So if I take the square root of x, I'll just have x on its own. But of course, if I take the square root of the right-hand side, I must take the square root of the left-hand side. So the left-hand side is y. Square root of y will be equal to x. Made x the subject, x is equal to the square root of y. Okay. Y is equal to 1 over x. I'm going to go, first of all, take the long route round to solving this one, and then I'll show you a quicker way of doing it. So, first of all, I want to make x the subject, but that means I want x equal. I don't want it to be 1 over x. So I want to get x to the top of one of the sides. If I multiply both sides by x, so I'm going to multiply the left and the right, I end up with y times x equals, well, I'm multiplying the right hand side by x, that would be x over x, or 1. Anything divided by itself is equal to 1. So I've got yx is equal to 1. But I still haven't got x on its own. So to get x on its own, I need to divide the left-hand side by y. But if I divide the left-hand side, I must divide the right-hand side. So let's divide both sides by y. X is equal to 1 over y. There we go. I've made x the subject of the equation. X is equal to 1 over y. Another way of looking at that, or another way of solving it, is 1 over y is, it should have been y is equal to 1 over x. That's our starting point. And again, I want to get x on its own. Well, y over 1, y is the same as writing y over 1. So I could write y over 1 is the same as 1 over x. Now what I can do is I can take the reciprocal of both sides. So I can, if I flip this right-hand side to give me x over 1, then I must flip the left-hand side as well, which will give me 1 over y. So 1 over y is equal to x. If you're happy with that, just basically taking the reciprocals of the left and the right, do it this way, it's quicker. If you're not, do it the longer way. There is no point in physics or maths or anything at all in life doing something quickly and incorrectly. The most important thing is to do things correctly and then hopefully as quickly as you possibly can. But correct is the most important thing. Okay, let's just take one more before we look at some real physics equations. Let's just look at a trigonometric function. Y is equal to cos of x. Well, again, I want to make x on its own, so I'm going to take the inverse function of x, which is what we call, well, it's written as cos to the minus 1. So cos to the minus 1 of y is going to be equal to, well, I take the reciprocal, sorry, not the reciprocal, the inverse function of cos x would just leave me x on its own. So x is equal to the inverse function of cos y. And if you look on your calculator, you will see there is a cos minus 1 as one of the options. Again, I have made x the subject. Okay, let's just try and put some of those things together now. Here's a more complicated equation. Y equals 1 over the square root of x plus 5. And let's remember what we're trying to do. We're going to try to make x the subject of the equation. Why don't you pause the video now and see if you can make x the subject. Okay, let's go through it and see whether we agree with the same answer. So the first thing I'm going to do is I'm going to get rid of this plus 5 from this side. So I'm going to take 5 away from both sides. So y minus 5 is equal to 1 over the square root of x. I want to get x onto the top now, so I'm going to multiply both sides by the square root of x. The whole of that is going to multiply both sides by the whole of the square root of x. So multiply by square root of x. Well, whatever I do to the right hand side, I must do to the left hand side. So we're going to end up with the square root of x multiplied by y minus 5, because I'm multiplying all of the left hand side by the square root of x, is equal to, well, I would have the square root of x over the square root of x, which of course is just the same as 1. So far I've got the square root of x multiplied by y minus 5 is equal to 1. But I'm still trying to get x on its own. So I could maybe divide both sides by y minus 5. If I divide the left hand side by y minus 5, I'm going to be left with the square root of x. And the left hand side will be 1 over y minus 5. And then finally, I want to make x just x on its own. I don't want the square root of x. So I'm going to say, I'm going to square the left hand side, because that'll get rid of the square root. The square of a square root is just the number. And I need to square the left hand side. 1 over y minus 5 all squared. Now I could multiply out those brackets. I'm not going to bother at this point. You wouldn't normally have to do that when you were rearranging for physics. So I'm going to leave it just as that. Okay, let's look at some real equations. Or some real physics equations. Some of these you'll have come across, some of you may not have come across, but if you're going to do the whole of the physics course, you will have come across them at some point, or you will come across them at some point. So here's one from the electricity topic. Power is equal to current squared multiplied by resistance. And I would like you to rearrange to make I the subject. Pause the video now and give it a go yourself. Okay, let's see whether you got the same answer as I'm going to get. So first of all, I'm going to get rid of the r. I'm going to divide both sides by r. I've got p over r equals I squared. And now I'm going to square root both sides. So let's take the square root of both sides. That will give me I on its own on the right hand side. And I'm square rooting p over r. So I equals the square root of p over r, making I the subject. Just so you're aware, another way of writing square root of p over r is p over r to the half. Sometimes it can be a bit neater and a bit more convenient for you to use that indice of a half instead of the square root sign. Okay, let's try another one. Another equation for electrical power is it's equal to the potential difference squared over the resistance. Can you rearrange this time to make R the subject? Okay. First of all, I'm going to try to get R onto the top of this particular equation. So I'm going to multiply both sides by r. So I'm going to have p times r is equal to v squared, because I'm going to have r at the top and r at the bottom when I've multiplied by r, so the r's will cancel. Now to get r on its own, I need to get rid of this p. I'm going to divide both sides by p, so we get r is equal to v squared over p. I have made r the subject. So resistance is equal to potential difference squared divided by power. Okay, another one from the electricity topic. This is for parallel resistors. 1 over the total resistance is 1 over the resistance of resistor 1 plus 1 over the resistance of resistor 2. And this time I'd like you to make 1 over R1 to be the subject. So what can we do here? Well, if I want to get 1 over R1 on its own, then I want to take 1 over R2 away from both sides. So I want to minus 1 over R2 from both sides. So I'm going to have 1 over RT is equal to, oh sorry, no it's not, minus 1 over R2 is equal to 1 over R1. I've taken 1 over R2 away from the right, which gets rid of the plus 1 over R2, and on the left hand side I've got 1 over RT minus 1 over R2. Okay, one from the light topic. This is for a diffraction grating. Don't worry if you haven't come across it yet, but the distance between the slits multiplied by the sine of the angle between the 0 and nth order maxima is equal to n, which is the order of the maxima, multiplied by the wavelength. Let's make this a little bit tricky. Let's make theta the subject. Theta the subject. Pause the video now and see if you can solve this one yourself. Okay, let's see how I'm going to get on with this. Let's first of all divide both sides by d. That's going to leave me sine theta on its own on the right. So I'm going to end up with sine theta on the right, sine theta on the left. I forgot my left from right there. Whatever I do to the left hand side, I must do to the right hand side. So I'm going to divide n lambda over d. And then finally, I want theta on its own. I've got sine theta, so I'm going to take the inverse function of sine, which we call sine minus 1. And I'm going to do that to the left-hand side, which will get rid of the sine function here altogether. But I must do that function to the right-hand side. So I'm going to end up with theta on the left-hand side and the inverse sine function of n lambda over d. I have made theta the subject. Okay, I hope that was useful. You find lots and lots of examples. Just work through the equations on the datasheet and see if you can arrange each of those equations and make each of the variables the subject. Thank you for listening.